This session is Modernizing the Ext JS class system. My name is Don Griffin, and my Twitter handle is here. In the season of politics, I feel compelled to offer you a fact check. You can go to our website and see if any of these claims are true. You'll have to trust me for the moment that this is about the Ext JS class system, though. So we'll get in here and start taking a look behind this curtain and see what we're going to talk about. So the whole thing kind of breaks out into two broad categories, and we'll run through them. More or less a background, what's going on with the language, what we want to do with the language, how we're going to bring language features into the framework, and then we'll look at the landscape of tools out there. And I think if we were to take a survey, we'd probably find that there are some clusters, but a ton of different tools in use to do builds and all of this, and we'll look at that landscape and how that affects our choices here. So then we'll get into the class system proper and look at some of the content that's happening in there and what's changing, some new features that are showing up, some capabilities, and some trade-offs that we've had to make between these goals of compatibility and future-proofing. Most interesting among the content items are modules and how they play in versus, say, class names. Who's been using Node and played with modules and some experience with modules? So, okay, so it's pretty prevalent. That's kind of the way JavaScript standards have gone. So we'll address those. And we'll look at how classes and mix-ins are affected by all of this. And then lastly, we'll hit some lifecycle points, but mostly about how those changes in the language have made some adjustments in our lifecycle. And then lastly, we'll look at a timeline. So I know that that's probably the first question everybody wants to know is when will all of this show up? And we'll look at that timeline there at the end and closing. And word of warning, there are some code names coming, so don't hold true to those. And the next 6 months might change some of those names, but they're coming, so beware. All right, so in terms of goals, really, if you think about it, we've already touched on those in the keynote, kind of what your hopes are for a new version of the framework, a new major version. Someone said they wanted the upgrades to be hard. We didn't listen to that. We listened to everybody else that said they want it to be easy. So really it comes down to trying to find a balance between two competing forces. So on the one hand, we've got compatibility. On the other hand, we've got future-proofing. We want our code to look modern and be modern, but we also don't want any of our code to break if we can help it. So that fight sometimes feels a little lopsided and unfair, but really what we're looking for here is to make sure both are respected equally and that it's a fair fight between all of these issues. And I think you'll be pretty happy with the outcome here. So kind of in the Vegas theme, we're going to put up some scoreboards here and give you some odds. So Ext define works as before versus class syntax everywhere. That's a one-for-one battle out there. Existing code organization with Sencha command packages is supported. Module-based structures are first class and right at the top. Ext require based on class name works as it always has, but import and export are also supported. So which one of those do you think might win out? Call parent versus supercall. If you want to do strict mode, we have to move away from call parent because call parent relies on features of the language that have been restricted in strict mode. And then lastly, Ext is a global namespace, but well, if you go down to the module world, you'd really want it to be scoped to its module. So here's the winners and the losers on all of that. So there you go. Everybody's a winner. If you placed a bet, you won. So basically, we're pursuing a goal where all of those things are equally true, and that in the end, Sencha's going to provide an upgrade tool that walks through your code and can do the smallest change, which we need for language compatibility, which we'll see, all the way up to rewriting your require statements into import statements and changing your Ext define calls into class keywords if you want. So you'll be able to run that tool and get a really big leap into changing your code over to modern standards if that's what you want. If you don't, you can pretty much stay exactly as you've done it. So as you can see, a big part of this whole idea is to build off of language standards. So language standards are really there to take care of the problem that tools create, and it's going to be a very interesting turn in a moment because tools change all the time. And if you've been watching the JavaScript tool landscape, you'll see, over here 18 to 24 months ago, the hot thing is now out of phase. It's not what anybody wants to use anymore. And few mourn the passing of these tools as they come and go. Grunt, then Gulp, Webpack as it goes, they all change over time. But the language kind of is our friend, and it stays with us and it grows and evolves. So we're really leveraging that, and we'll show how the tools come back to be a help in this, but you'll see there's also two edges to that sword. So I know that a few of you mentioned IE support is important, and you'll see IE's report here in just a moment. But we'll start with the winners. Obviously, Chrome at the top has pretty much 97% for the longest time. So it's doing great. Opera, using the Chrome engine, is doing fine. Safari caught up with a vengeance in Safari 10. But if you have to support Safari before 9, you're looking at IE level of standards compliance there. So not that great. Firefox is making steady gains all the way. And then Microsoft got out of the starting gate eventually, and with Edge has been making steady gains. But if Windows 7 matters to anybody, I should ask, does it matter to anybody? Windows 7, kind of a target. And if you're on Microsoft browsers, the end of the line is IE 11, so that's going to be kind of the dark horse to consider when we talk about language adoption. But there's an interesting statement. If you go look at MDN and you go read these statements about all the new great syntax, the import statement is not supported on any browser. And then when you go to the standards, you find, well, by the way, the standard isn't fully baked either. So really, we want to do some stuff that's on the track of standards, hasn't arrived in standards and fully, and hasn't arrived in browsers at all. So what does that 100% mean? You know, they must be cooking the books, I guess. It's Vegas, so there you go, 100%. So really, this is the blessing of tools, that tools enable language adoption. So if you want to use those things that aren't supported in your browser, tools are the only way you can go forward. And what they do is they enable us to take the language and bring it to the current day before the platforms out there that need to run our code are ready to run it. But this is what I was mentioning before. The challenge here is, which tool do you pick? Well, if you had asked that question 2 years ago, you probably got Gulp. 4 years ago, Grunt. Today, Webpack has broke out and is in the lead. And we expect that will be the continuing trend. There'll be new tools and there'll be new approaches, and everybody is going to change these things out. So how do we deal with that volatility on the tool side of the world and use still these tools for what they're good for to bring language to us today? And this was already mentioned, the code name again, Sencha build, might not be called that. It's our open tooling platform, and based on Node.js, so whatever tools you're using out there, you'll be able to bring these things in, look at the code inside them, figure out what they're doing, if they're doing what you need or they need to be tweaked. So open sourcing on all of those tools. And then when we hit a particular thing like Webpack, we're building a very thin layer in there. We're not putting all the logic in a Webpack plugin or all the logic in any other plugin for any other build system. We're just building thin layers in here. So in the future, when, of course, the inevitable comes and the tools evolve and a new thing becomes the thing, whatever that thing might be, and we've looked at several, we'll have the ability to build equally thin layers in those tools that leverage Sencha build and the open platform that has to do all the heavy lifting and then integrate with that build tool. So under the covers, the good parts of these tools that we want to leverage, because that's really what unlocks the language adoption, is transpilers and source maps. So who's not heard of these before? New concept, never seen before. So a handful of folks, it's a strange word for sure, transpilers, but really this is one of the better parts of the tools. So what is a transpiler? Babel's a good example. If you want to Google on Babel and transpilers, you'll find a handful. They're really JavaScript to JavaScript compilers. They take modern JavaScript and produce JavaScript that you can actually run in a browser somewhere. So they go beyond polyfills, and that's a word for just missing APIs. I need an API that's not there, like promises or some method on the array prototype. If that's not there, you can just put it in there or call an ext method that does the same, but language syntax can't do that. So right now today, as you saw before, transpilers are it when it comes to actually implementing ES6 fully. If you want imports and you want exports, you're in transpilers. There are no browsers that support that, but that will change over time. So we can future-proof our code by using these tools today. Decorators is also Mark mentioned in the keynote, we'll look a little more at. Those are an upcoming standard, a lot of popularity. Angular 2 loves these things. They're really useful, and we'll see how they fit in, but also you need transpilers to do that. So again, this is what the goal is. So Transpilers are going to unlock that. They're going to let us write code that won't be natively runnable for some time, but we can write it today, so when that future comes, our code, the stuff that we invest in, spend all our time in building, that code doesn't have to change. Maybe our tools will change underneath, but the vast majority of our effort is preserved. So if you've ever had to deal with the development prior to Transpilers, it's always been least common denominator. What'll work everywhere I need to target? What methods on array, what language syntax, what features, and that's kind of gone for the most part. There are some things that can't be transpiled back. There are some APIs that simply cannot be implemented on an ES5 browser, but as you saw, the majority of all the evergreen browsers are well beyond implementing this stuff. But if you're targeting IE11 or old Safari, you need to be aware that not everything in ES6 can be fixed by tools or by polyfills. So who's ever had to debug the output of a compiler before? It's an awesome experience, I recommend it. Not really, but with a source map, the whole idea here, of course, is to get me mapped back to my original source. Don't make me look at whatever that transpiler, compiler, tool put in my file. I know that the browser loves it, I hate it. Make me happy and put my source code back up here. And some really good news on this front is this technology has been around for quite a while. And that's great because what that means, it's widely supported. All those evergreen browsers, they've got this covered. And the shocker, actually, I was pretty surprised. IE11 actually has this, but only in the Windows 8.1 update. So if you've got to target Windows 7, you need IE11 support on that. You might want to develop or look at developing on Windows 8 or newer so that you can get source maps, still same old IE11. So hopefully mileage won't vary much on that. So these tools are great, they're fantastic, they save us a lot of time, and they enable us to write modern code. But as always, you have to ask the question, what's it doing really under there? Is this magic for free? Is it something I can rely upon? Well, I guarantee, I'd say 99%. You can trust them, but you probably want to verify what they do. Because if you're using them in performance critical areas, you want to know, is that output that's actually running in the browser good stuff or is it inefficient stuff? And if you look behind the source map, which you really should, like I say, it's recommended to know what's coming out, they do produce some very scary code. And this is probably one of the biggest takeaways. When you're using transpilers, the goal should be transpile the least that you can. And with imports and exports, that's needed, but that's pretty small. If you're transpiling the world down to run on IE8, you're going to have a very thick layer of transpiling going on. So the more language features you use, the more important that's going to be. It's really critical, of course, if performance or code size is a concern, because the output of the transpiler, while correct, may be disappointing. So that really limits our adoption, but not completely. It just makes us look more carefully at what we're doing based on our target environments. And that's really something you always need to be aware of. What is the target browser, minimum browser that I need to support? Adjust your transpiling and don't engage more than you really need to. And then this one was a bit surprising. I guess it shouldn't have been, but even without transpiling, some native idioms have surprising performance issues. And I've got a link at for a website down there, 6speed, and I highly recommend looking at it before you dive in too deep and just go crazy with all of the new language features, because they're great, but not all of them are free. And one of my saddest discoveries with the for of loop is very not free, and we'll see here in just a moment. So if you haven't met for of, Lee Boonstra has a session that'll give you a lot more details. But the awesome thing about it is it changes code that looks like this wonderful array indexing, into just a value walk through the array. Very nice, much better than that loop, more compact. But when you look at the performance breakdown, except in TypeScript really, which I don't know if that's type inference or just not conforming to the standard yet, everybody is slower, including pure ES6. So if you're running in a browser that supports pure ES6, you don't need to transpile for of loops away. Just be aware they're on the order of 3 to 7 times slower than a normal loop. So often that won't matter, but it might. Depends what you're looping and how often. So be aware that that all the candy might actually give you a stomach ache on some of this stuff. So that's kind of the backdrop. And So now we're going to transition into the kind of the core content. What's changing inside the class system to accommodate the language features and all of the things that we're looking at here. And this one is definitely the biggest paradigm shift in the group. So it's probably going to be the one that most people have to ask serious questions about. Namespaces versus modules. So Ext has, since its birth really, worked on the concept of namespacing. Namespacing really is a simple idea of nested objects. We have an Ext object, it's got reference to the global object, it becomes a member of the global object, and then Ext define is used to populate that namespace, and you simply have a nested object graph like this, and that's really what's going on. But there's a bit more to that story because the names are translatable to URLs, and we can then load those, and we can compile against those. So the name situation is leveraged not just for defining classes and making instances, but also for loading and for building. As you can see, some simple calls here to, there we go, setting the path. Just say, hey, my Ext code's over there, my app code's over there, so whenever I have a class name, it knows how to turn that into a path, and it's a nice decoupling. But that's pretty much unique to namespaces. The other thing that's worth noting, because it's just backwards with modules, is that all scripts that we load through namespace loaders are loaded at global scope. So if you put a variable in there at the top, it's a global variable. So with modules, they kind of peel it down. It's a simpler model, but there's less flexibility in trying to find the file you're interested in. So they are just files, but the nice thing about them is they execute in a private scope. So whenever you put a var like this foo up here at the top of your file, it's still local to that file. And you don't have to worry about colliding with other modules. So that's clearly a big selling point for modules. And then they use the export keyword to tell what pieces of their file they're going to give to the rest of the world. And then the rest of the world brings those in as they choose. But they can have one unnamed, one called default, and that really is export. So each file is kind of a freestanding thing, and it decides what it wants to give up. And then when you import it, you import by name or by path. But this first two are paths, so you just say from this file to that file, I have to go up and down to this path, and there's my place where the module is. And then I want this piece of data that it's exporting, a method, an object, whatever. So the naming can also be used for module names, but once you resolve a module name, from there it's still a path. So if you take these examples, code names again, for Ext JS kernel, that's a module, it's got a location, and if you want to use the named exports, you can see, but if you path into it, you can pull path files out of it. Again, that's just kind of how modules think. But that's the language standard, so to go forward into that world, we're bringing that in as a first class way to bring in code, to author code, to export code. So how's that going to show up when you're using our toolkits? If you're using toolkits in the way of modules instead of namespaces, there'll be several ways you can import the classes that come out of there. So the primary one that we think you'll see a lot is Ext. So we just take the button Ext, and it comes out of the modern codename warning inserted here package, and then that's the button component. And then you can also import by alias family, so the HBox layout. And then these tokens get used like you would have normally used strings if you're defining a view in a declarative way. You can still use the strings, by the way, but those are references to just 2 characters shorter and 1 lookup less to bring them across. This is kind of the last stop, so if you have something by a class name somewhere, you can always still import it by class name. You can't use dots because the things that you can import and export have to be valid identifiers. And so that was our current placeholder for import by class name, but we think this will be probably the minority. And then, like I said, these can replace your strings, but these named exports by alias or by alias family, Ext, those can be built for you by scanning your code. So the Sencha build will be able to do that if you want. And that's how we'll take all of our code, take all of the names, and extract them up into an index so we don't have to maintain 1,500 exports. And by name, by alias, by path, by all of that. So we'll just generate an export from map with the tool build tools. So the takeaway here really is that Sencha command understands namespaces, clearly, and that's its strong suit. Sencha build will understand modules. It's possible that command will grow some understanding of modules. That's not decided yet, but it's fairly certain Sencha build will only understand modules. It won't understand namespaces. But as I mentioned, there's a tool that we're going to provide that will translate namespaces to modules for you when you're ready, if you're ready. And you don't have to do that if you want to stay on command for this. So that's kind of the big module one, the most impacting one. Like I said, it's kind of an A or B choice, but both are options. Existing code obviously just can stay where it is. But classes really is another very interesting one because the whole class mechanism in ES6 offers us some constraints and some new features. And so we'll walk through kind of how those shake out and what they do to us and the impact they're going to have. So classes today, we're just going to do a quick survey through this. I'd ask who uses class system today, but that'd be unfair because everybody should, if you've used Ext. So you've got classes, they're defined, support inheritance via the extend directive. Other directives, all kinds of them for loading, for defining aliases, for platform configs, a variety of other things that the class system understands. Call those directives, and then there's just instance properties. You can put those in your class definition. Constructor, special name, that'll come back in a bit. Just normal instance methods, of course, and static methods as well. They go into a statics block, and that kind of completes the survey, except, of course, many of these need to be able to call their parent class. So they have to be able to, in some way, refer to the class that they're extending. And so the framework, since version 4, has provided call parent to do that, and it knows by virtue of the method you're calling it from who's the superclass and who's the method. And that mechanism will not port into strict mode. So if strict mode is in your future, call parent is not. So just be aware. So what that just produced when we ran that code, and memorize this, by the way, because there'll be a test. This is the class constructor, the static methods, prototype object that's going to contain the prototype chain for our inheritance and our instance methods, and then a reference back to the constructor. And then when we make a new instance of it, it gets prototype chained to that. So everybody's got this memorized, right? That's what we've been doing for years, so it should be old hat. ES6 now changes a few of these things. So syntactically first, we'll just kind of hit the big points. Imports, we've seen a lot of those already. Class keyword, export keyword, the new decorator that we're going to give you to mimic the missing features that the define system has. And inheritance now is part of the class system of the language, so we're going to leverage that. Any directives that you would have used in an Ext define call simply move into the define decorator. Instance properties as well. So as Mark mentioned, classes cannot contain properties. They can only contain methods or static methods. So the good news is methods go in nice and clean. Static methods clean also. And super calls are even cleaner now because with the super keyword, we can get access to the base class equivalent method, and we don't need to fight with strict mode. So these keywords work great with strict mode. So just a peek under the covers of what decorator's doing. They look kind of mystical, but they're actually quite a simple concept. They're functions. That's probably a shock from JavaScript. They're functions. And they decorate things that they're given as a parameter. And if you need to have additional parameters, like our define, it might look something like that, where you have a function call with some particular parameters, and it returns another function that will eventually be called with the class that you're going to decorate. So in the end, a statement like that syntax, is just a special way to call that define function that you saw, and it's equivalent to doing that. Essentially, that or that, same thing. That's what the transpiler is going to do. So the cost of transpiling here, obviously very low, but the value very high to make code very clean and straightforward. So as mentioned, it's currently a stage 2 proposal, but there's a ton of interest and energy behind getting it standardized. You can go look at the TC39 proposals if you want to track this and other future standards coming to the language. So now this one will look very familiar, but subtly different. So hopefully you memorized the last one. Here we go. This one, essentially, is our constructor. What's new here is that the constructor of our superclass is prototype chained to us. So that means whatever's statically on that is going to inherit just like it would have on the instance. So our static methods go there. We still have a property called prototype that points at the prototype object, and that's chained up in the same way as before. But now the subtle difference is that we have to respect the word constructor to mean that backlink from the instance to the constructor. That's pretty much a requirement in ES6. And so our solution is to rename the construct method as what was the constructor method. And this is one of the jobs that the upgrade tool will do. It will walk through all of the code in its minimum setting and simply take OR off of constructors. And now you're done. So like I said, you don't actually have to memorize it because I figured out we can do a morph, and there you go. That's the underlying difference between today and ES6. So there you go. So this kind of leads to this mention about constructors. What's the big deal with them? And the big deal is that really in ES6 classes, constructors have some serious restrictions, and this is the big one. They can only be called with an operator new. So if you write a class like foo here, and you say new foo, it's great. It's going to call the constructor, assign that property, and on we go. But if you tried to use it with call or apply, thinking, well, if a class constructor is, after all, just a function, you'll be sad because in the end, it's not a function anymore, it's special. And you get an error thrown at you that says you can't use a constructor like that. Now, if you're running through a transpiler, you won't see this message, but if you're running native ES6 code in a native environment like Node or Chrome, you will get that message. And so we have to adjust the coding paradigm slightly, and that's why the OR has to go off of our method. Right, so now let's get into the mixins, because I don't know who uses mixins in their designs to implement strategy. Okay, fair number, that's great. Very handy thing. So another way to look at mixins really is they're a form of multiple inheritance. And we've kind of all known that. It's just like, I'm like this mostly, but I've also got this characteristic and that characteristic and just put them together. So they don't fully behave like bases because JavaScript only has one that can behave like that. But they are classes. So they start as a class, they can have methods, they can do whatever a normal class can do. And then when you want to use them, you just use the mixin directive. And then that mixin directive can mix in one or more other classes. All of the content from the prototype will be copied in. So now that method there will be available. So if I have an instance of thing here and I call the method, it just will find the one we copied from up there. So I don't have to implement that. So that's all great until there's a collision. When you already have a method, you need to override the method. Things get a little more complicated. And so we provide the mixins object, which gives you access to the prototypes of all of the mixins that are there. So now with that, you can simply say, great, I can call my constructor, right? Well, if you were following, that's a bad thing now, right? You can't do that because once the constructor is a constructor, that call will throw a type error at you. So this call will not, and so that's really the backstory for the change there. And again, this is part of the tool's job to go through, find these calls, and take the OR out and get your code up to ES6 conformance, even if you don't want to go all the way and use classes. So Mark stole a lot of my thunder in that talk, by the way. So what do mixins look like in ES6? So we kind of did a sneak peek at that. But here we go. We're going to look at, there's still classes, and there's good reasons for that, as we'll see in a moment, around lifecycle management. But so they're classes. They extend Ext.Base, and you use @define to bring them in. And I've shortcutted that a little bit because I have another way to bring them in that we're adding to this release. And that way we'll treat them much more like base classes. So if you've ever struggled with that use of mixins dot my name of my mixin and the method and calling and all, then with this form you can use the extend word directive, and it knows you've already got a base, so but it now treats that mixin a little differently, and it'll bring it in underneath anything that is already existing. So then when you call it with the normal supercall. And so that means now that mixin method, even though it's in conflict, is still available to you in the standard way that a base class would normally be available to you. But in all other ways, it's basically the same thing as a mixin, just different way to bring them in method order. So now when we hit all this talk about mix-ins, one of the biggest challenges mix-ins have had over time is making sure that things can initialize properly and clean up properly. Because once you have all of these graphs of objects calling their mix-ins and providing logic of their own, you wind up in a bit of a quandary at times. So with the new release, we'll be adding a more straightforward and consistent starting in Ext.Base lifecycle. Some of this will be old hat, some of this will be new. So we'll hit kind of the old hat stuff first. So when you create it, obviously we use new. We're not just calling functions and returning instances from them. We do use new, but of course there are factories that do that internally, and they'll return new instances. But the native constructor, if you're writing ES6 classes, you'll be able to extend any class that we've written with define or with the class keyword, and you can use the native constructor. One of the restrictions about the native constructor is before you touch your this pointer in any way, read or write, you have to call the super constructor. You can't use your instance at all before you do that, or it will throw an error at you in a conforming implementation. That's a good thing, according to standards. So it's not how our normal construct method has worked in the past, because we couldn't enforce that. But that is how native constructors work. When they're needed, that's fine, but as you'll see, there's really not a huge need for doing them, unless you're writing very, very small, very simple classes. It's totally great. But in general, like using components and things, probably not recommended. And we'll see why here in just a bit. So the construct method is the new name for constructor from current framework. And it's available in all classes, be it ext define or class keyword. And it's essentially just an instance method by that name. And so it can be called not first in your construct method if you want. Just like today, you can do some work in line and then call the super construct method. So that's the new name for the old thing. But if you've used the config system before, so now I'm curious, has anybody used the config system to define their own configs? Handful of folks? A few, that's good. So some improvements around managing that coming through here. So we do recommend that you use configs as a directive when you want to define properties that change over the life of an object. It gives you a really easy way to know that it's changed, that you need to take a side effect possibly. There's a setter method generated, so it's all managed and you don't have to worry about that. So when it gets to when those things change, how do you do your work? Well, if you've delved into the config system, I don't know how well everybody's discovered this, but when you call set foo, then you can transform the value with an applier, you can run an updater, and that will take the incoming value that's new now, we know it's different, and then you can do your side effects. So Ext.Base in the new framework will have a single argument constructor that it will look for. And if you pass a single argument to it, that's a cue that you want those properties applied to the instance or run through the config system. And so Ext.Base construct, if you land there, because a lot of times today, if you write your own constructor, you don't bother to call the Ext.Base constructor. That's still fine from the construct method, you don't need to do that. But if you do, then a init config will be called when it's needed. So if you pass that object through, or you've defined config properties, it'll automatically call a init config. So those classes where you have one line in your constructor that just calls a init config, you can delete that. And just let the Ext.Base take care of that. So destruction, Ext.Base has had that for a while as well, but there's a couple of nuances worth mentioning. So it sets up a couple of flags so you can always know what state my object is in. Am I in the middle of destroying it? Have I just destroyed it? And the important part here is it only allows one time through. So if I have an object, I need to destroy it, well, it may already be destroyed. This will prevent accidentally rerunning your cleanup calls twice. So it does that by just avoiding that second call. And then this one is relatively new to 6.2, but we'll maintain it here in the new version, is of clearing out all the instance properties. So that's very handy for avoiding memory leaks. It's very, very easy to forget to clear things out. But if you're using the Ext.Base's destruct sequence, then you don't need to worry about it. If you've written your own, you still have to worry about it. But when you get up to the base, it's now going to just loop over and clear out any references. So this is the new part. So one of the challenges with mix-ins is around initialization and cleanup. How do you make sure that happens? How do you make sure I don't do this twice? How do I get that implemented reliably in a bigger architecture? So these are another code name. These names may change, but the idea here is that we needed a template method that's guaranteed to be called, that's always going to be called in the right order, on initialization or on teardown. And we need to get that instance initialized, but we also need to make sure that all our bases and all our mix-ins and their bases and their mix-ins and whatnot have all been dealt with so that I don't have to worry about who's calling whom here. And we'll see an example in a minute of why that's kind of challenging at times. And the destructor method here is very similar. It's all for cleaning up, and the key is make sure to call the most derived thing before you get into the bases. And you don't actually implement any supercalls with these. They're scheduled uniquely in an order, and we'll see the example here in a minute. And so they're just called automatically. Now these are an interesting twist, but hopefully this will make some sense here. So if you've got a mix-in, and you're defining a hierarchy, so I've got a base, and then I've got another class derived from it, and then I have some construction logic here. As you can see this, I've just taken a simple constructor method, renamed it, and then it's got some parameters. So it's kind of a very straightforward way to think about initializing an instance of a simple class. But there's some side effects that come along with each of those. And then when I go to do my mix-in, I now have this diamond shape where C is bringing in B, but base as well, and now I have to deal with both of these things. And it would be great if, in fact, I didn't call the base level construction twice or the base level destruction twice. It's just inefficient, pointless, and possibly error prone if that's one of your bases in the middle there that's being converged on. You can end up running code twice that you don't want to do. So what would that look like with these template methods? We're going to move X to be a config. So now instead of doing this in a construction phase, I just do it in my update X method. Whenever X changes now, over the life of the object, X2 will be maintained for me, and I don't have to worry about it getting stale. This one, we're just saying this Y property, permanent, not going to change. So during construction, just set up the other derived value and leave it be. And then when we hit where we're bringing the diamond together, all I have is another CTOR, and it pulls X and all these other properties. And then we call it through the object form. So the real difference at the code level of use is right down there. That's an object instead of where it was just a pair of numbers. So that leverages the common object lifecycle. And now, as you can see, a lot less code here. And the most important part is what are the guarantees of those calls. They're called once per class. So the one that's in Ext.Base, if there was one, would be called just once. The one in A would be called once, top down, always. And then for the destruction sequence, again, just once, and going from derived to base order back up. So make sure that objects get cleaned up and initialized reliably. Is anybody here with us when we transitioned from 4.0 to 4.1? Kind of curious. Has anybody used the observable and got burned by the change we made to observable initialization? So this was one of those cases where we had a mix-in that we gave to the world, and it had no necessary construction initially, but then eventually over its maintenance, it needed a property. So we put the constructor in and we did the initialization. And then of course, nobody had bothered to call the constructor, and it didn't cause any problems until we had initialization needed. And then it broke a variety of folks, and they had to figure out how to weave in that call. So that whole mechanism would never, or this mechanism would have prevented that kind of problem. Would never have occurred. So if you don't want to adopt all of that, that's just fine, because that happens inside the base implementation of construct, calls our CTOR methods, and the base implementation of destruct calls the detour methods. And if you don't like those methods, you don't want to do those, that's fine. Just don't call the base version. Write your own life cycle, and it's totally fine. And inside of those, we gather up that set of methods I was mentioning as needed. So if you never call these things, you don't pay any price for that ability or that feature. So we've been very cautious as we walk through looking at what we're going to do with the core of the system to make sure that everything is pay-as-you-go as possible. If you don't use something, you don't pay for it. And so that's true of the new common object lifecycle. If you have your own lifecycle, you won't see any downsides bringing this one in. So now we're up to when is all this going to happen? Well, some of it's today. As you heard, Sencha Command 6.5 is out in EA, and it, under the covers is using Google Closure Compiler. If you care to know what language level that enables in your code, I recommend you go check out the compat tables. You can see exactly. It scores fairly highly. But a lot of the things that can't be done, just obviously they can't do, like proxies and such. They do also provide a lot of polyfills. So if you are using ECMA6 methods that don't exist, those will be provided as well. This is a key point, as we mentioned in the onset of this. Transpiling is optional. So if you guys plan to see the Electron talk later today, you're going to want to turn transpiling off. Electron natively understands like 97% of ES6. And so for the command 6.5, now your code can still be built, turn transpiling off, and no harm, no foul on the transpiler. It won't corrupt things for you. By that I mean make them less efficient, of course. And to make that really work out, we need to have our own compressor. So who loves YUI compressor? Hopefully nobody raised their hand on that one. But the UE compressor has been the cause of many issues, and it is now replaced with our own, and it understands how to minify native ES6 code. So even when you don't transpile, you can still minify your code and not have to worry about long variable names and local scopes. Closure compiler cannot do that today. Uglify is in progress in doing that today. So to my knowledge, the only product that does that today is Sencha Command. And so that's where we are today. And then next, Sencha Build and Sencha Command are coming together. You can pick which one you want to use for the next major release. Be an upgrade tool to move you across. Highly recommend you see Ross's talk. This is kind of a part 2 of this talk for peering into the transpilers and the build tools and all those other details. Ross is going to go into those. And as mentioned, the estimated landing zone of all of this is probably the second half of next year. So that's kind of where we're targeting, but you know, estimations are estimations. And there we go. So we've got time for some questions, I think. All right. Completely stunned everybody. Lunch is over, it's nap time. All right, but good news is we have a few moments for questions and answers. So I've got questions. Oh, sorry. Okay.
This might go more into the tooling and stuff like that, but the idea, like, if you start using modules, imports, and stuff like that, you should be able to have the JavaScript code, just general JavaScript code as NPMs or some sort of module just imported into your classes using inside of Ext code is no problem.
Right, so the question is, can we use just off-the-shelf modules and import them and bring them in? And obviously, that's the big goal with Sencha Build and the new move to those platforms, is to let you do that. Now, the modules you bring in, of course, it's kind of on you to make sure they work for your target environment and everything, all that, but absolutely, yes, that is the plan. You just have to get the loader configured and the builder configured, and then it can resolve those module names, and you can NPM install them, or nowadays Yarn install them, and yeah, off you go. Yes?
So we use a lot of packages to do things today, Sencha packages. How does this apply to?
Okay, so how does Sencha Command packages apply to Node packages? So the first thing to take away is Sencha Command isn't going away, so all of that's still going to work. We will be making sure that Sencha Command package JSON files can cohabitate as Node package JSON files. So we'll basically take all of our own properties and wrap them in a Sencha object and put them in there. So I think we're going to land that in Command 6.5. So if you have that conflict already, that Command 6.5 will allow that one package JSON to fit both roles. And so that's kind of the beginning of it. But I think the harder part, or the harder question, is how to consume that package off in another place. And if you, as the package developer, want to allow your user to be a module-based user or a namespace-based user, but again, Sencha Build, when we get to that, will be able to generate, like I said, these big indexes. So you can think still namespace, and you can use @defines and whatnot to put names to all your classes, and then that indexer can create an import index out of those names for module-based usage. So it should be pretty straightforward to set it up so that a package could go both directions in consuming it, but it'd be easier if you picked one, but you know, so status quo, mixture, or whichever. Yeah.
Messier to make this ES6 make your code look. I mean, I noticed you have to pull the configs out of the class definition and put them above the decorator and things like that.
So
is the readability still there? I mean, it looks like it.
Okay, so the question is, what does the new syntax do to the readability of the code? And I would say that When you're looking at a view, especially, like we saw in the keynote, where the defined decorator is all of it, and you have the class name and the extend at the bottom, and that's the end of it. It's certainly a pattern. I've been in some discussions with the standards group to allow that decorator to go onto the constructor so that you could put it inside the class and kind of have a more logical flow. But it's currently invalid to put a class decorator on the constructor of the class. So at the moment, that's the syntax we're stuck with. But as you saw, it's a simple transformation at the end. If you preferred to put the payload of that defined decoration at the bottom, it's actually a very short method in there that takes what's in that body and applies it to the class. So because as we're returning those closures to implement decorators, we don't want the closures to have a lot of logic in them. So really, they're very short calls off to methods in the class themselves. So yeah, you can kind of pick your style as you prefer. But yeah, the language simply doesn't allow you to put everything into the body. So yeah. Will Closure Compiler? So currently, Closure Compiler does not support decorators. Babel is what we're using on the Sencha build side. So Sencha Command 6.5 will not have decorators or class system level kinds of support in it. It's really just the language of functions, arrow functions, loops and syntax and all of that. But the high level stuff like modules, classes, and decorators are really coming latter half of next year with the Sencha build platform. So yeah. We're looking at that. We'll see what we can do, but we're kind of relying on Closure to do most of the work. How are we doing on left? Okay, a couple more minutes, so a couple questions more. Yeah. So the question is source maps and Firefox in particular. I'd have to get Ross, I'd ask that in Ross's talk, the next one, because he's going to run and actually do some demos with Webpack and source maps and all of it. So my experience so far has been overly positive, especially in Chrome. Obviously, that's where it's great. But in Firefox, I haven't used it myself directly in their debugger. I guess, I don't know if Firebug versus the native experience, the new dev tools, I don't know which one's kind of ahead of the pack right now, but you could always try the alternate one and see if it's any better. But yeah, obviously with all the tools moving that way, there's a lot of pressure on these folks to get their debuggers to really work with source maps, and that's only going to continue as people make the leap over. All right. Over here. Okay. All right, so the question is what version of Ext JS will the transformation tool support? And we're targeting anything that's based on Ext.Define. So if you're following that, that would be version 4 and higher. If you're, I do believe we added a very primitive Ext.Define to 3.4.1 or so. So it's in there, but it's not full featured. It's very, very basic, but I don't think the tool would understand that. And most ext3 apps don't use it anyway because it came along so late as a kind of bridge to help get people moving slowly across. But definitely, obviously working backwards, 5 and 6 for sure, 4 most likely because it's still based on the same core class system. All right, I think we are one question. We have time for one question in the back. Oh, that's a great question. I'm glad someone asked. Overrides, how do they work in the new class system? The answer is yes, they still work in the new class system. So with strict mode, that's a bit of a challenge because if you're trying to call parent, and that's the thing you can't do, we have new forms of Ext.Define that will allow you to receive an overlay that lets you call through or bypass the replaced method. So it'll look a little different, and it'll be slightly different syntax. But if you need to be strict mode compliant with your overrides, you'll be able to do that. But it will be Ext.Define based. There's no other way to do an override. All right, well, thanks everybody. It's been great fun, and enjoy the rest of the session.